So another important piece of the dynamic setting of competition is thinking about strategic barriers to entry, right? And so what we want to think about is a two-stage game where we have a monopoly incumbent, which we'll call firm one, and they have to decide whether to invest in some sort of project in stage one that will lower its marginal cost in stage two. And so we'll actually think of different types of projects. And then in stage two, firm decides whether or not to enter. So firm two is that potential entrant that we've talked about in the past. If entry takes place, then they're going to compete simultaneously by choosing output, like in a Cournot game. And then we'll also look at an example where they will compete in price, like in a Bertrand game. So how to find the subgame perfect Nash equilibrium, again, we have to use backwards induction. And so we can think about the best response function of firm one and firm two. And the idea, so if firm one doesn't do anything, we're at this Nash equilibrium that is the intersection between best response one and best response two. But if firm one can invest in the research and development, or even it could be advertising, then that will shift the best response function to the right and will be here at any prime where the new best response function meets firm two's original best response function. We wouldn't expect firm two's best response function to shift because they're the potential entrant. Now notice that in this case, the way it's drawn here, firm two is still going to enter, right? They still want to produce a small amount, even though firm one is producing most of the market share. Firm one would have to shift their best response function all the way past Y in order for it to be a successful barrier to entry, right? And if they were able to do that, then firm two would be like, oh no, my best response to that output is 0, right? And so I'm not going to produce at all. So Futtenberg and Tirole sort of look at 4 different possibilities. So 2 with a Cournot type model and 2 with a Bertrand model. And thinking about whether firms will overinvest or underinvest than if there was no potential entrant, right? And so all that they mean by overinvesting or underinvesting is comparing it to how much they would invest in the R&D or the advertising or whatever it is that the project is in stage one if there was no potential entrant. And so they call these 4 models Top Dog and Lean and Hungry in the Cournot case, and Fat Cat and Puppy Dog in the Bertrand case. So looking at the Cournot case first, the Top Dog is similar to the one that we already looked at, where investment in X, whatever X is, right, research and development, advertising, whatever, causes firm one's best supply function to shift to the right, like it did in the graph we already looked at. And so in this case, firm one is going to overinvest in X in order to create a hostile environment for firm two. And that could be either because they're trying to keep firm two completely out or whether they're accommodating entry, but they're going to invest in more in X than they would otherwise. The other example in the Cournot style game is what they call lean and hungry. And in this case, the best response function actually shifts to the left, right? So from BR1 prime to BR1 in the figure we had before. And so they give an example in the book where it might be profitable for firm one to enter into another market, but because of diseconomies of scope, it's going to push up their marginal costs in the original market. Maybe it's just too expensive to operate in both of them. And so they're going to choose not to do that. So this behavior is not going to deter entry. Now, when we think about this in a Bertrand style setting, we have to think about different best response functions because now, of course, they are competing in prices. So now we have price one on the horizontal axis and price two on the vertical axis, and we have upward sloping best response functions. And our original Nash equilibrium is here where they cross. And then if BR1 shifts to the right, we get to a new Nash equilibrium. And so the 2 examples that they talk about here, the first one is Fat Cat, where it does shift to the right. And so in this case, investment in research and development might enhance quality of firm one's product. And so that would be a shift in the right of their best response function. And so because now they have a higher quality product than firm two would have, that's going to soften price competition, as we saw earlier. And so they then are sort of a non-aggressive fat cat. I guess the idea is that they're the big firm, and so they don't need to compete as aggressively. The other example they give is if the investment in X causes a leftward shift in the best response function, so BR1 prime to BR1 in that last graph. And this would happen, for example, if the research and development led to a reduction in firm one's marginal cost. And now, in order to avoid price competition in stage 2, firm 1 will want to appear non-aggressive by underinvesting in X, and so they won't invest as much as they otherwise would. Now, I think we also still have to think about whether or not they could invest enough that it would keep firm 2 completely out of the market, and that is certainly a possibility, as we saw in the earlier chapters, right? If you can reduce your costs enough so that you are lower than everybody else, then in a Bertrand style game, you can still earn profits by pricing just below whoever would be the next lowest cost competitor, and then still get some profits there.